Hey folks, today we're going to be learning about interpreting the discriminant. It's very connected to what we learned yesterday with the quadratic formula, which is from my song, which you probably have all watched and now have memorized the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, the discriminant is embedded in the quadratic formula. It's actually this little piece right here. This is what we call the discriminant. And depending on what its value is, it can let us know if a quadratic equation has one root, two roots, or no real roots. So what do I mean by real roots? So say I was given an equation like this. X squared minus 3x minus 10 equals 0. Now, the easiest way to deal with this is we can factor it. X minus 5, x plus 2 equals 0. So we know we have actually two real roots. We have x equals 5 or x equals negative 2. If we have two real roots, then the discriminant is going to be greater than 0. Think about it. If it's going to be greater than 0, then we're going to have plus, so negative b plus the square root of b squared minus 4ac over 2a, and we're going to have negative b minus. So there are going to be two distinct roots. So if I were to say, give you this quadratic equation and say, how many roots are there? You could factor them and say, oh, there's 2, or you could use the discriminant. So if I were to use the discriminant, I would say this guy right here is our B, our A is 1, and this guy right here is our C. So I would say b squared minus 4ac, because that's the discriminant, in this scenario equals negative 3 squared minus 4 times negative 10 times 1. We simplify it, 9 minus negative 40, so it's actually going to be plus 40. So we have actually 49. Since the discriminant is bigger than 0, the discriminant is 49, we know that they're going to be two different roots. And when we factor it, we know that there are two different roots. There are two different solutions. Remember yesterday? We did the quadratic formula with this example right here. X squared plus 2x plus 7 equals 0. When we plunked that into the quadratic formula, we got a root like this. X equals negative 2 plus or minus the square root of negative 24 over 2. What we did here is we said, whoa, stop. This has no real roots because we can never take the square root of negative 24. So what does, so we said no real roots. We can use the discriminant to decide that already. So using discriminant, I'm going to say b squared, which is 2 squared, minus 4 times a, 1, times c, 7. So we have equals 4 minus 28 equals negative 24, which is less than 0. So quadratic equation has no real roots. It shouldn't surprise us that the discriminant, which is this piece right here in the quadratic formula, gives us the exact same number here. Those two things are the exact same. The only thing that we haven't talked about yet is the idea of having one root. So quadratic equations that have one root are perfect square trinomials. So let's look at one. So let's take something like x squared minus 10x plus 25 equals 0. We know that that's a perfect square trinomial because when we factor it, we actually get x minus 5 squared equals 0. So there's only one root. There's only one value for x that will bring this whole thing equal to 0. And guess what, guys? It's x equals 5. I want to take a little bit longer on this one because the quadratic formula actually gives us something that's pretty cool. If I would say the discriminant, using discriminant, well, we have our b, which is negative 10. So negative 10 squared minus 4 times a, which is 1, times c, which is 25. Well, that just equals 100 minus 100, which is 0. Since it equals 0, we can say 1 real root. All right, so let's think about it. If the discriminant is 0, it means that this portion of the quadratic formula is 0. So then we're adding 0 and subtracting 0. Okay? So we would have two different, in general, we would have two different solutions. But since this is 0, we would be adding and subtracting 0. That doesn't make a whole lot of sense. All we would be left with is negative b over 2a. All right, so let's take some summary notes on that. b squared minus 4ac is called the discriminant. Because it discriminates between types of roots or solutions. Whenever I say roots, I also mean solutions. Now, I'm going to put stars beside this because this is important. If b squared minus 4ac is greater than 0, the equation has two distinct real roots. If b squared minus 4ac equals 0, the equation has one real root. If b squared minus 4ac is less than 0, the equation has no real roots. That means the equation is not solvable. So I'm going to give you some time here so you can pause, so you can fiercely copy this down.